Regular expressions have long been a go-to tool for parsing documents, but they have one main issue. They often struggle with the complexity and variability of real-world PDFs. Large language models, on the other hand, offer a more flexible and powerful approach to handle different varieties of PDFs, depending on their structure and their content type. In this video, you will learn how to leverage large language models to build a document parsing system that I believe will change the way you think about AI and its capabilities. If you're ready, let's get started. Now, how can I use LLMs to parse PDFs? Let's consider this simple example. On the left, we have PDFs that we want to parse, and we submit those PDFs into the processing block. The processing block uses long-chain unstructured PDF loader to process PDFs, like extracting the contents of the PDFs. And once we have the contents of a specific PDF extracted, we combine it with the document's prompt. The document prompt is the prompt specific to a given document. If we have a research paper, then we have the prompt for research papers. If we have a document related to healthcare, then we will have a prompt specific to healthcare document. And the large language model now parses the content of the PDF document with regards to the prompt that it received. And once we have the metadata extracted, then we save for each PDF file a corresponding JSON. So this is overall the workflow of what we are going to achieve in this tutorial. Now let's start with the data that we want to process. The first one is this first research paper, Performance Study of YOLO 5 and Faster CNN for Autonomous Navigation Around Non-Cooperative Targets. The second one is the well-known research paper, Attention is all you need. Both documents are research papers, and the goal of this parsing is to extract for each document the title of the research paper, the authors of that paper, those who contributed to that paper, their institutions, their emails, and also the abstract. Once we extract the abstract, we are also going to summarize that abstract. And the final thing that we want is the publication date of the research paper. So once we have all these things in mind, we then need to create a prompt that will hold all this information to be extracted. So here I have defined that prompt. So what does that prompt say? How does that prompt work? The goal of the prompt is to be submitted to the LLM. And for the LLM to better understand our inquiry, then we need to provide a better description of that prompt. We start off with this first statement saying scientific research paper. This is telling the LLM that the document that we're dealing with is a scientific research paper. And here is a placeholder. That placeholder is going to be used for each PDF document that we are going to submit. And here is where all the description starts. You are an expert in analyzing research papers. Please carefully read the provided research paper above and extract the following key information. We are mainly interested in 6 keys. The first one is the paper title, which is the full title of the research paper. So every time we give the key, which is the property to extract, then we define what that property means, because the LLM itself does not know exactly. And the first thing is the publication year, the year the paper was published. The third one is authors, the full names of the authors of the paper. And we also want the author's contact. The author's contact is going to be a list of dictionaries where each dictionary contains the following key for each author. We have its name, which is the full name of the author, its institution, its email. Now we also want to extract the abstract of the paper, and also the summary of that abstract. Okay, now we have defined what are the properties that we want to extract. Then we need to provide a guideline to the model. The guideline are also things that need to be followed by the model. First thing we tell him is that the extracted information should be factual and accurate to the document. Then we are getting more concise. Be extremely concise except for the abstract, which should be copied in full. Then the model does not need to invent anything outside of what is within the research paper. The extracted entities should be self-contained and easily understood without the rest of the paper. If any property is missing from the paper, please leave the field empty rather than guessing. For the summary abstract, focus on the main objective methods and key findings of the research paper. And final guideline is for author contact, create an entry for each author, even if some information is missing. So here we want for each author the information to be at least like provided. If that information is missing, then we leave it as an empty block. And now we want, since we want the response to be in a JSON format, then we tell the model answer in JSON format. The JSON should contain 6 keys: paper title, publication year, authors contact, and so on. And these 6 keys are those that we have highlighted here. Great. So once that we have that prompt is going to be used by the LLM to extract the required information from the research paper. Now we can dive into the technical implementation. And the data that I have shown before, the book 2 research papers, I have downloaded them in the data folder. And also the prompt is in the prompt folder. And this folder extracted metadata is currently empty, but that's where we are going to save the results of the extractions. We start with installing the libraries. The main libraries will be unstructured, OpenAI, PyPDF, and the remaining ones are dependencies that need to be used by those libraries to avoid any installation issues. So we start off with the installation of those libraries. After installing the libraries, we import the main ones: OpenAI path, OpenAI class, PDF reader, user data, which is used to access our credentials. The partition PDF function is used from unstructured to process PDF file, and we have additional functions from Tenacity that we are going to understand moving forward. Now we set up the credentials: the OpenAI key, the model ID, and also, those are the 2 main keys that we're going to use. The OpenAI key, to get access to those credentials, we can see them here. OpenAI key is here. That's the name of my key, and the value is here. The same for GPT model is here. You can see that the GPT model that I'm using is GPT 4.0, and I set up those credentials here. And now let's run this. Now we can start with the metadata extraction, but the first component is data processing. The data processing, the first function is the one that is going to read the prompts for PDF files. So we open the prompt in read mode and we return the content of the prompt. Now we have extract text from PDF. That extract text from PDF is using the unstructured partition PDF function to get all the content of a given PDF and concatenate each content with a break line, and all the content is returned as a single block of text. And here's something interesting here is that we are getting also We are setting strategy to high resolution. For PDF files containing images, this is going to be useful because we want the highest resolution of images where we are also going to extract the content. With document processing, at this stage, we already have the prompt, the content of a PDF file in a text format. Now we start with the document processing function. For document processing, we have that completion with backoff. The completion with backoff is going to use the decorator retry, because sometimes when using OpenAI model, we can hit some rate limitations and we want the function to keep trying and over again until we reach success. Here is the function to extract metadata. That function has the contents of the PDF in text format, the prompts that we want to give a model, and the model ID, which is the model that we are using to perform the extractions. First, we read the prompt, and here is where we are providing all the model with like the main attributes and instructions to extract the contents. First, we need the model ID, which is the GPT-4o we have specified above, the prompt data and the content. Now we set the temperature to 0.2. You can increase or decrease the temperature at the level you want. Here we extract the contents of the model's response, which is given by getting the content fields of the final result. And now we are removing any markdown code block indicators in the results and setting it to the proper formatting as expected by the model. So in case of failure, we return the failure error. Otherwise, we print the raw response of the model in JSON formats and we return the JSON response of the model. For each PDF, we want that response to be saved in a specific JSON format. This is what is going to be performed in this process research paper. So this is going to take a research paper, a prompt, the output folder where we want to save that JSON file, and the model that we are using. So basically, we are performing three main steps. The first one is to extract text from the PDF. So this is used by the extract text from PDF function. The step 2 is to extract metadata using the GPT model, and this is where we use the extract metadata function that we have implemented here. This is going to extract the metadata. And the third step is to save the result of a JSON file. Now we get the file. We want to save the file with the same name but different extension. This is where we are saving as a JSON file. And here the remaining block is basically saving that file with indentation of 2. Let's execute this block to make sure that we are able to use those functions. Okay, now we have our functions ready. Now let's see how it applies to a single file. We are giving the path to the PDF that we want to process, which is this specific research paper. I think it's the V7 one. This is the attention is all you need research paper, 15 pages. So this is the one that we are going to process. And the prompt, we give the path to the prompt that we are using. The prompt is here. The prompt, like prompt slash scientific paper, which is this prompt. And now we run the process on research paper for this specific document. Here we can see that all the steps have been successfully executed. We have extracted the text from the PDF, extracted metadata using GPT-4o, saved the metadata to the extracted metadata folder. Let's see what it looks like. So here the extracted metadata folder has the JSON file for the research paper that has been processed. The paper title is Attention is All You Need, publication year 2017. Here we have a list of all the authors who contributed to that research. And for each author, we have the institution. For instance, we have Ashish Vaswani, who is from Google Brain, and his email address is here. So let's see what it looks like. Ashish from Google Brain. Here we have Ashish from Google Brain, and here his email. No one from Google Brain as well, and no one at Google. No one from Google Brain, and here is the email. So this is how we extract, this is the result from the model after extracting the content, which is wonderful. This is wonderful. And here is the abstract. The dominant sequence transaction models are based on complex, recurrent, or convolution neural network that includes, and so on. Here we have the abstract that has been extracted by the model. So the model has extracted the whole abstract. And in addition to that, we told the model to create a summary of that abstract. Here is a summary provided by a model for that abstract. This is wonderful. This is really wonderful. So once we successfully do this for a single document, we might want to run the same process for like all the documents in a specific folder. And this is what we are doing in this function, process directory. So this process directory is going to process all the PDF files that we have in a specific directory. So it takes the prompt, the directory path where we need to search for the PDF files, and the remaining things are like basically the same as the above function. So we iterate through the folder, we check if the folder ends with a PDF, and we now start the processing. Okay, and now we define the argument for that function. The prompt path is the exact same prompt that we're using. Directory path is where we are searching for PDF files that we want to process, and the output folder is the same output folder that we have specified. Here we can see that the processing has been performed for both files that we have in the data folder. Let's see what we initially saw this one, which is the attention is all you need. Now let's have a look at the second one. The second PDF file is this one, performance study of YOLO 5, autonomous navigation around non-cooperative targets. Now let's have a look at the remaining fields. We have here all the authors, Trupti Mahendrakar, Andrew Ekblad, and so on and so forth. And also the author contact. We have, for instance, Trupti Mahendrakar, who is from Florida Institute of Technology, and its email is here. And let's see if that is correct from the research paper. Trupti Mahendrakar, Florida Institute of Technology, and here is the email. So let's randomly pick someone else. Isaac Silver from Energy Management Aerospace. Isaac is Energy Management Aeroservice, and here is Isaac email. And here is also the abstract, autonomous navigation and path planning around non-cooperative space object is an enabling technology. Let's check that here. Autonomous navigation and path planning around non-cooperative space object is an enabling technology for non-orbit servicing. As you can see, we have successfully extracted all those fields in addition to that field, which is the summary of the research paper. The model has successfully summarized the abstract of the paper. So here is, like, as you can see, there is a lot of benefit of using such metadata, because we can save it later in a relational database for future references. And this is something where a regular expression will really struggle extracting. It will struggle extracting this type of content, or at least if we manage to write the script, it will be difficult to maintain. But with this technology, anyone can successfully create something related to creating such powerful document parsing. We have seen the example for research paper, but we can also like extend that to other types of documents. And I will say that the main task here is prompting. Prompting is everything. If we fail the prompt, then the output of the model is going to be is not going to be good quality. Well, if you like this video, give it a thumbs up, share, leave also in the comment section what you like me to cover in my future videos. And also, I would like to know your opinion on how you think this type of technology can be useful, in which fields you want it to apply. Thank you for watching and see you next time. Bye bye.